Hi everyone, I'm Yashwantam, student of SVCA Bangalore. My branch is CSC and the subject is Discrete Mathematical Structures. Introduction to Permutation and Combinations. Permutations and combinations are fundamental concepts in discrete mathematics that help us to understand how to count the number of possible arrangements in selections of set of items. These principles are widely applicable in fields like portability, statistics, and computer science. Fundamental counting principle. The multiplication principle, and second is subsets and sequence, and third is probability applications. In multiplication principle, if there are m ways to do one task and n ways to do another task, then there are m x n ways to do both tasks in succession. In subsets and sequences, permutations and combinations allow us to determine the number of possible subsets or sequence of a set of an item. Third one, probability applications. These principles are essential for calculating probabilities of complex events involving multiple steps or choices. Permutations. Arrangement order. Permutations are the number of ways to arrange a set of items in a specific order. Second one is formulas. The formulas of permutations is NPR equals n factorial by n minus r of factorial, where n is total number of items, r is the number of items being arranged. Applications. Permutations are useful for problems involving seating arrangement, passwords, and scheduling tasks. Factorial notation. Definition. Factorial notations represented as n factorial is a way to express the product of all positive integers less than or equal to n. Examples. For instance, f factorial equals f into 4 into 3 into 2 into 1 equals 120. Applications. Factorial notation is essential in calculating permutations and combinations as well as in probability and other areas of mathematics. Permutations with repetition, ordering, and applications. Firstly, in repetition, when items in a set can be repeated, the formula for permutation becomes NPR equals n to the power of r. In ordering, the order of repeated items matters as they are considered distinct arrangements. Applications. Permutations with repetition are useful for problems involving passwords, license plates, and other scenarios where order is important. Combinations. Selection order. Combinations are the number of ways to select a subset of items from a set where order does not matter. Formulas are The formula for combination is NCR equals n factorial by r factorial into n minus r of factorial. Applications. Combinations are useful for problems involving choosing committees, selecting lottery numbers, and determining the number of subsets of an set. Comparison to permutations. Combinations focus on the selection of items while permutations focus on the arrangement of the items. Combinations with repetition. Repetition allowed. In combination with repetition, the same item can be selected multiple times. Formula. The formula in NCR equals n plus r minus by of factorial by r factorial into n minus of factorial. Applications. Combinations with repetitions are useful for problems involving selection items from a limited stock or budget. The binomial theorem. Definition. The binomial theorem describes the algebraic expansions of powers of an binomial expressions, and the formula is a plus b the power of n equals ncr into n to the power of n minus r into b to the power of r, where r ranges from 0 to n. Applications are: the binomial theorem has applications in probability combinatorics and algebra. Pascal's triangle. Definition: Pascal's triangle is a triangular array of numbers where each number is sum of two numbers directly above it. Relationship to combination: the numbers in Pascal triangle represent the coefficients of the binomial expansion, which are same as the combinations formula. Applications: Pascal's triangle is a application in combinatorics, probability and number theory. Applications of permutation and combinations. Probability. Permutations and combinations are essential for calculating probabilities of events in games of chance. Computer science. The concepts are fundamental for understanding algorithms, data structures, and information theory. Business and finance. Permutations and combinations are used in inventory management, portfolio optimization, and decision making. Scientific research. These mathematical tools are employed in experimental design, statistical analysis, and model development. Thank you.